Okay, good morning to all of you. I welcomes to all in our lecture series on optics. That is your core paper 4, belongs to second semester, and we starts to discuss about unit 2, that is your wave motion. Okay, today we are going to discuss about the relation between simple harmonic motion and wave. Okay, so let's start. So here, carefully watch this dynamics. You can see a pointer is revolving on the circumference of a circle and corresponding projection oscillates along y-axis. Okay, that means whenever it is moving, the pointer is moving on this circumference of the circle for one full rotation. See, here starts and covers the whole angle and reaches the same position. So to cover total full rotation, that means it covering 2 pi angle, and with each angle we have the displacement along x-axis of this projection, or you can say of this particle. So this particle have its particular position along y-axis for each and every angle. Okay, see, the particle this point are moved from here to here. If here to here, the projection is here. If the pointer moves, see, moved here to here, the projection is here. That means for particular position on the circumference of this pointer, corresponding projection will be also a particular uh, displacement from the origin. So carefully, if you are going to be watch, we can found whenever it is rotating on the circumference periodically, then this particle oscillates periodically, or we can say it executes a simple harmonic motion along y-axis. Now for each and every angle, if we are going to be uh, estimate the displacement along y-axis, and we are going to be put the corresponding angle and its corresponding displacement, then we can found this type of geometry, which will be nothing but called as your wave. And if it is will be continuously move on the circumference, then this particle is going to be oscillate continuously on this along y-axis, and we are going to get a wave which will be seems to move along positive x-axis direction. So here the simple harmonic motion and wave equation are directly related with each other. So if we can found the equation of this simple harmonic motion, that equation will be useful or acceptable for the wave motion. Okay, so for now we are going to find out the equation of the simple harmonic motion. For this, what I done that the whole circumference, here the whole circumference is there, and the particle starts from A and rotates on the circumference, and let particle starts from A and rotates 2 pi angle and came to the same position. Let for the whole circumference, or to cover whole 2 pi angle, the particle taken the time t, suppose capital T, and I divided the time is t by 8. That means I divided this circumference 8 parts. So if 8 parts, then time taken for each part will be t by 8. So this will be t by 8, this will be t by 8, this will be t by 8, this will be t by 8. So each and every section covers by the particle on the circumference will be taken by the time will be t by 8, right? Now we have to consider that the particle, yes, when the particle is moving on the circumference, here you can see at when it will be at A, the projection will be O. When it moves from A to B, the projection is M. This will be the displacement, instantaneous displacement. When it moves from A to B, this point moves from O to M. When B to C, moves from M to C. When C to D, again it moves from C to M, like that. So when the particle moves on the circumference, this point, red point, moves along y-axis simple harmonically, right? Now we have to find out this instantaneous displacement. For that, we consider a instantaneous. This is the instantaneous displacement of this projection, right? For that, we consider a instantaneous displacement of the particle on the circumference. So initially it is at A, and at time t, suppose after time t equal to t by 8, it moves from A to B, and let the angle covered is theta. If this angle will be theta, draw the perpendicular from B to M. So obviously this angle will be theta, right? Now we have to consider the triangle OBM. OBM. This is the right angle triangle. This is the your 90 degree. This is your diagonal, and this is your base. So sin theta will be equal to OM by OB. OM by OB. Sin theta will be equal to OM. OM will be nothing but y instantaneous displacement divided by OB. O to B, the distance is r. So that implies r will be equal to, sorry, y will be equal to r sin theta. Now here you can see that the particle A covers whole angle in time t. So that means in time t, it means the pointer covers angle theta equal to how much? 2 pi. So in time, in unit time, it covers an angle will be how much? Theta will be equal to how much? 2 pi by t. So in t by 8 time, that means from A to B, how much time taken? T by 8 time taken. So in t by 8 time, covers an angle theta will be equal to 2 pi by 8 into t by 8 will be equal to pi by 4. That means this angle is pi by 4. If I am going to put theta will be pi by 4, it will be r by root 2. Okay, so if we are going to take angle along x-axis and displacement along y-axis, then at pi by 4, the displacement is your r by 2. Okay, now we have to consider another displacement, that the particle is at initial at A and it covers the distance this much on the circumference, and time taken 5t by 8. So we know that in t covers 2 pi angle. In 1 means unit time, it will be 2 pi by t. In 5t by 8, it covers 5 pi by 4 angle. So y equal to r sin theta, that means y equal to r sin 5 pi by 4 will be minus r by root 2. So here minus r by root 2 means this distance. So this is your minus r by root 2 distance, right? So if we are going to consider 5 pi by 4 angle, the displacement along y-axis will be equal to how much? Minus r by root 2. So here we can found that for each angle its corresponding displacement we can found. So the oscillation and wave are interrelated with each other. So the equation, that means this equation of oscillation is also called as equation of the wave. That is your y equal to r sin theta, right? Now here we have been considered a situation, any instantaneous point. That means suppose A will be here at any instantaneous point, A dash is here. That means theta is anything. Theta is anything. So here if we are going to consider this will be theta, then by this will be theta, this will be also theta. By triangle O A dash M, this distance will be called as r sin theta, y equal to r sin theta. Okay, so we know that in time t, the pointer covers the angle 2 pi. In unit time it will 2 pi by t. This 2 pi by t is nothing but is your angular velocity omega. So in time t, it will cover the angle theta will be equal to 2 pi by t into t. 2 pi by t is nothing but omega, so omega t. So instead of theta we can write r sin omega t. This is again another form of the wave equation or simple harmonic motion. This t is represents any instantaneous time, Now we have to go for the phase and phase difference. So just now previously we found r equal to nothing but r sin theta equal to r sin omega t. Y is your instantaneous displacement, r is amplitude, omega t. Here omega t is nothing but called as the phase. Here omega t is represents an angle, but in this wave motion, it is also called as the phase. Okay. So what is exactly physical meaning of the phase difference? Here you can see. Suppose two particles A dash and B dash. A dash is at an angle theta equal to omega t, and B is the particle which is angle phi. This angle is phi. That means B will be with the angle theta plus phi. You got my point? A dash particle E will be here and with the angle theta equal to omega t, and B will be here and this angle is phi. So initially these two particles will be here and here. Now when the time starts and both the particles revolves on the circumference with a constant angular velocity, then this angle will be always remains there in between the two particles. That means whatever may be the situation, or at any time if we are going to be observed, then we can found the angle between A dash and B will be phi. That is nothing but called as your phase difference between A dash and B. So here in which way we can represent mathematically? Suppose we are going to write for A dash, this is the instantaneous displacement. If this will be the instantaneous displacement, this is the theta, we can write y equal to r sin theta. So here for displacement along y axis for this A dash particle is nothing but y equal to r sin theta or r sin omega t. Now for B, this is the displacement. Let this is your y equal to r sin theta 1. So here theta 1 means this whole angle. Theta 1 means whole angle. Whole angle means omega t plus phi. So y1 will be equal to r sin theta 1. That means r sin omega t plus phi. So here we can give the language that B particle always ahead of A dash. B particle always ahead of particle A dash by a phase angle. How much? Phi. And the so-called y1 displacement is r sin theta 1 or r sin omega t plus phi. Now we can consider another situation. Now suppose A dash is here, B is here. At time t equal to 0, this is the situation when they are moved. Then we can found the phase angle between the A dash and B is phi. But here the equation will be somewhat different. How? See, for A dash, what will be the displacement? It will be, if we are going to consider this whole angle will be theta, then it will be r sin theta or r sin omega t, right? If the angle phase difference between A dash and B equal to phi, then what will the displacement of B or this OM for the B position, for the B particle, what will be the displacement along y axis? That will be y equal to r sin theta 1. Here theta 1 is nothing but this angle. Okay, this angle will be equal to how much? Omega t minus phi. So here we can say that B particle, here one can say that B particle always lacks of A dash by a phase angle phi. Always lags, always lags A dash by a phase angle phi. Okay, so it can be written as y1 equal to r sin theta 1 equal to r sin omega t plus phi. Okay, so in general, any displacement, any instantaneous displacement will be represented by r sin theta 1. This theta 1 may be omega t plus phi or maybe omega t minus phi. Okay, so on the base of lagging and ahead, on the base of situation of the two particles, it will be plus phi or it will be minus phi. So in general, it can be written as y equal to r sin theta 1 or equal to r sin omega t plus or minus phi. So thank you so much for watching this one, and I suggest that for phase difference, topic, you can write this one. This you draw this figure and write down this equation, and again you draw this figure. So see, for phase and phase difference, no need to draw this all the things, no need to draw the wave itself. Only draw the circle and mark A dash and B, this angle, and write down this one. And similarly for this figure, no need to locate these points and time and all the things. Only you just draw the x-axis and y-axis, mark B and A dash, and mark the theta and phi, and write down the equation. Okay, and at last you have to write, in general, y, the displacement or the instantaneous displacement will be represented by r sin omega t plus or minus phi. Okay, so thank you so much for watching this video. Thank you.